expected values. It's how much, on average, you expect to get. Let x be a random variable. Let x be a random variable. The expected value of x, which is denoted by E for expected of x, E of x. And this is equal to all the little x's that x take on times the probability of x. Add them all up. Whatever x can be, whatever value big X can be, multiply it by its probability. If x can be yet another value, find the probability and multiply them together. For example, if x can take on 0, 2, 5, and 7, and the probability of 0 is 1/10, let them all be 1/10. The probability of getting 2 is 3/10, and of getting 5 is 2/10, and then of getting a 7 is 4/10. I tried very hard, and it looks like I succeeded in having those probabilities add up to 1. So the expected value, E of x, is just multiply x by P of x. 0 times 1/10, which is 0, plus multiply these numbers. 2 times 3/10, plus multiply those numbers. 5 times 2/10, plus lastly 7 times 4/10. Do your arithmetic, whatever it turns out to be, that's your expected value. You multiply it, all the values that x can be, one by each of the corresponding probabilities. For example, if you toss a die, and x represents the value that is face up, what's the expected value? That is, when you toss a die, on average, what do you expect to get? Now, you may never be able to get that value. Like if the expected value can be 2 1/4, for example. But you can never roll a 2 1/4. But in the long run, if you add up all the tosses and divide by the number of tosses, make believe it'll be 2 1/4. Okay, so we toss our die, and the random variable x is the value of the roll. What's the expected value? So you have x, you have P of x. What are the values the possible values when you roll a die? The answers are, not 0, sorry, but rather 1, 2, 3, 4, 5, or 6. You can get a 1, or a 2, or a 3, or a 4, or a 5, or a 6. And the corresponding probabilities, well, each value has the same probability of coming up, 1/6, 1/6. So the expected value, E of x, is just, actually it's denoted with a box around x. E of x is just this product plus this product plus this product, etc. And if you look at it carefully, every product has 1/6 in it. You can factor out the 1/6 and just add up 1 through 6. To convince you more carefully that that's true, 1/6 times 1 is exactly the first product, plus 1/6 times 2 is exactly the second product, and so on, finally, until you get to 6 times 1/6. And this is 1/6, and when you add up 1 through 6, I guess you get 21 times 21. 3 goes in here 7 times, 3 goes in there 2 times, 1 times 7 divided by 2. You expect to get 7 over 2, or 3.5. That's your expected value. You expect to get a toss of 3.5. That's kind of why when you roll 2 dice, the expected value is 7, and that's the sum that comes up the most. You roll 2 dice, the number that comes up the most is a 7. You multiply x's by p of x. Figure out what values x can take on, figure out their corresponding probabilities, and multiply them together. Okay, now here's a great problem. Suppose you were going to take a 2-question test. You're going to take a 2-question test, and you decide which one you're going to answer first. You decide which one you're going to answer first. You decide which question to answer first. You can only answer the next question. I don't want to say question number 2. You can only answer the next question if you got the previous one correct. That is, if the first question you answer is correct, then you can go on and attempt the last question. If you did not get the first question you attempted right, you cannot try the second question. So if you tried 1 first and you got it wrong, you can't even try number 2. If you tried 1 first and you got it right, then you can try 2. Or you can try 2 first. If you got it wrong, you can't try question 1. If you got question 2 right, your first question that you answered, number 2, was correct, then and only then can you attempt question 1. That's what this is asking. And I'll give you some probabilities. Okay, first let's say you get 5 points on the test. If you get question 1 correct. So the test is going to be in the form question 1, question 2. So I'm not saying you're doing 1 first or you're doing 2 first. I'm saying if you get question 1 correct, you get 5 points. You get 7 points if you get question number 2 correct. Again, there's only 2 ways for you to get question number 2 correct. And that's if the first question you answer is question number 2 and you're correct. Or you did question 1 first and you got it correct, and then you went on and got question 2 correct. Okay, now, like I said, some probabilities. The probability that you know the answer to question 1, let that be 1/4. And the probability that you know the answer to question number 2 is 1/3. To maximize your score, which question should you answer first? Which question should you do first? So, I guess one needs to do this problem twice. Suppose you do question number 1 right. Okay, suppose you do question number, maybe I said it wrong. Suppose you attempt question number 1 first. Well, what can x equal? Well, you can get it wrong, and then you get no points, and you don't even get to try question 2. Or you get question 1 right, and then you go on and you get your 5 points. But you go on, when you go on to question 2, you get it wrong. So you only get 5 points. The other thing is, you can get question 1 right and question 2 right for a total of 12 points. Now, what are the corresponding probabilities? If x is 0, that means you got question 1 wrong. Well, the probability that you know question 1 is 1/4. We'll assume that if you know it, you'll get it right. The probability that you get question 1 wrong is 3/4. The next probability is you get question 1 right, but question 2 wrong. That's the only way you get 5 points. And the probability that you get question 1 right is 1/4. And the probability that you get question 2 wrong, well, if you get it right, it's 1 out of 3 times. So 2 out of 3 times you'll get it wrong. And 2 goes into the bottom 2 times. You get a 6th. The probability that you get 5 points is 1/6. Okay, now what is the probability that you get 12 points? Well, first you have to understand how you get 12 points. You get 12 points by getting question 1 right, which happens 1 out of 4 times. And you get question number 2 right. 1/4 times 1/3 is 1/12. Now, I'm interested in the expected value. How many points you expect to get on this test if you answer question 1 first. Well, you multiply these two numbers and you get 0. So I won't write this. You multiply those numbers. 5 times the 6th is 5/6, plus you multiply these two numbers. 12 times the 12th is 1. So you expect to get 1 and 5/6 points on this test if you answer question 1 first. Well, now, what if you answer question number 2 first? What can x be? Well, there's 3 scenarios. And the bottom row will be p of x. You can get question 2 wrong, and then you get no points at all. Or you get question 2 right, and you get 7 points, but you don't get question 1 right. Or you get question 2 right and question 1 right for a total of 12 points. Now, what is the probability that you get 0 points? That is, you get question 2 wrong. Well, the probability that you get question 2 right is 1/3. 1 out of 3 times you'll get it right. So I guess 2 out of 3 times you'll get it wrong. I'll do the probabilities up here. What is the probability that you get 7? Well, that means you get number 2 right and number 1 wrong. The probability you get number 2 right is a third. The probability that you get number 1 wrong, well, you get it right 1 out of 4 times. So you must be getting it wrong 3 out of 4 times. This is just a quarter. Okay, what is the probability that you get all 12 points? Well, you have to get 2 right, number 2 right, which happens a third of a time, and then you have to get number 1 right, which is the 12th. Oops, and put the 12 down nicely. Okay, so E of x will simply be this product, which is 0, plus this product, which is 7 quarters, plus 12 times the 12th is 1, plus 1. So you're going to get, remember, this is 1 3/4, plus another 1. You get 2 3/4. And remember, the original question was to maximize your points, which question should you do first? The answer is question number 2. Of course, based on the given information, you will get 2 3/4 points. Whereas if you answer question, you would expect to get 2 3/4 points. Whereas if you answer question number 1 correct, you only expect to get 1 5/4. Now, what does this expect mean? I want to really emphasize what it means. It means if you took this 2-question test 1,000,000 times and you added up all the scores and you divided by 1,000,000. Now let me be clear. We're assuming right now you do question 1 first. You do this experiment or this test 1,000,000 times, answering question 1 correct. These probabilities do not change. The point values do not change. If you add up all your scores and divide by 1,000,000, you'll be very, very close to 1 5/6. If you answered question number 2 right and you did this experiment, a huge number of times, 1,000,000 times, and you add up all the scores from the 1,000,000 exams, take the average, that is divide by 1,000,000, you will get very, very close to 2 3/4. If you think it's not close enough, don't worry, do the experiment 1,000,000,000 times. It'll get close. It's what you expect to get. This is a nice problem. I like this problem. I'll put it on my next probability test. Okay. Suppose you have 120 people. You want to put them on 3 buses. So you have 120 people. You're going to put them on 3 buses. Bus 1, bus 2, bus 3. Bus 1, suppose it has 36 people. Bus number 2 is 40 people, and bus number 3, 44 people. And it adds up to, these 3 numbers add up to 120. So all 120 people, they're split up into 3 groups. One group is called bus 1, or one group goes on to bus 1, another group on to bus 2, etc. Now, you're going to choose somebody at random. Choose someone at random. And let the random variable x equal to the number of people on that bus. That is, the bus that this randomly chosen person came from. take pieces of paper, same size please, with all 120 people names, put them in a hat, randomly pick a name which corresponds to a person. So you chose someone at random. And let the random variable x be the number of people on the bus that has the person who you just randomly chose. Okay. So, now what's the expected value? What's the expected value of x? Well, what numbers can x take on? Well, x is the number of people on their bus. X can either be 36 people, or 40 people, or 44 people. What is the probability of x? What is the probability that x is 36? What is the probability that you pick somebody from bus 1? If you randomly pick somebody on one of the buses, what's the probability they're from bus 1? 36 out of 120. The probability somebody is from bus number 2? Answer, 40 out of 120. From bus number 3, 44 out of 120. So the expected value, E of x, is just this product plus this product plus that product. 36 times 36 over 120 plus 40 times 40 over 120 plus 44 times 44 over 120. First thing I'll realize is in each term I can divide top and bottom by 4. I'll divide this top number by 4 and this bottom number by 4. This top number by 4, this bottom number by 4. Actually, I could have divided by 8. This top number by 4, 44. And this bottom number by 4. Let's do it again. Divide the bottom number by 2. Divide the top number by 2. Divide the top number by 2. Divide the bottom number by 2. All the bottoms are going to be 15. Divide the top number by 2. So the bottom is 15. 9 times 18. Well, 18 is 9 times 2. 9 times 9 is 81, times 2 more is 162, plus 10 times 20. If you have 10 20s, you have $200. 11 times 2. 22 is 11 times 2. 11 times 11 is 121. Times it by 2, you get 242. And this is over 15. You have 200, 400, 500, and 60 and 40 is another 100. That's 604. 604 divided by 15, which, quick check on my calculator, gives me approximately 40.27. Their expected value of the person on the bus, or the number of people on the bus associated with the randomly picked person, is 40.27. Now notice something. The average number of people on the bus, there's 120 people, and you're putting them on 3 buses. On average, each bus will have 40 people. yet the expected value was a little bit more. Think about why that could possibly be. Okay, let's try one more problem. This is our expected value is very big when it comes to gambling. How much money do you expect to make each time you play a game? Or how much? Now remember, we can always talk about how much you make. Well, if you make negative $2 per game, that just means you lose $2 a game. Suppose you enter a game where if the spinner lands on red, you lose $1. Okay, red, you lose $1. If the spinner lands on black, you win $3. If it comes on black, you win $3. And the probability that the spinner lands on red is 2/3, and the probability that it lands on a black color is 1/4, 1/4. What is your expected gain? If you play this game, how much do you expect to win? So, they ask for expected values. You need to figure out what x times all the possible all the x's times the probabilities and add them up. Okay, if you play this game one time, you can either lose $1 or you can win $3. The probability that you lose $1, that means red came up. The probability that red comes up is 2/3. 2 out of 3 times you will lose $1. You play this game 3 times, you should expect to lose $1. 2 times. 2 out of 3 games, you expect to lose $1. So play 3 games, you expect to lose $2 because red came up. But that doesn't mean you're never going to win. The probability that you win $3 means the probability that black came up, which is 1 in 4 times. 1 in every 4 times you play, you win $3. Now, do you win or do you lose? You multiply these two numbers, you get negative 2/3. Plus, you multiply those two numbers, you get 3/4. Let us get common denominators. Let's multiply the first fraction by 4/4 and the second fraction by 3/3. Why is that? Because 3 times 4 is 12 and 4 times 3 is 12. Negative 8 plus 3 times 3 is 9. You actually win. You actually win. Okay. So you win a 1/12 of $1. You win a 1/12 of $1, which, if I'm not mistaken, is 8. Right. Yeah, it's 8 1/3 cents. So you should play this game. Every time you play it, you win 8 1/3 cents. Okay, if you can play 1,000,000 times an hour, you'll win a little more than 8 cents 1,000,000 times. Remember, this is the 1/12 of $1. If you can play 1,000,000 times an hour, you win a twelfth of $1,000,000 every hour. In 12 hours, you'd win $1,000,000. At least you would expect that. Expected values is very important in gambling games. It helps you know whether or not you're going to win or you're going to lose. Okay, and if you're going to break even, you play the game for the fun of it. But if you're going to win, that's very interesting. It's very, very interesting if you're going to win. Okay, because if you keep playing, you're going to win on an average. In this game, I think it was 8 1/3 cents each game. And if you can play a lot of games, you win a lot of money. Okay, this completes the section on expected values.